In our next example, problem 2, we are still multiplying powers with the same base, but now we're dealing with algebraic expressions. So we're going to break this down by, first I'll highlight just the coefficients, so the 5 and the 4, and rewrite these first. So we have 5 times the 4, because numbers we can multiply together. And next we'll focus on the variables, x to the power of 7 and x to the power of 3. So now we're multiplying this by x to the power of 7 and by x to the power of 3. So I rewrote this so you can see what's being combined or multiplied together. So in the first part, we're multiplying this 5 with 4, so 5 times 4 is 20. And now we're still multiplying powers with the same base, which we just learned. The shortcut is to just add up the exponents. So this is going to become x to the power of, what is 7 plus 3? 10. Okay, let's use the same idea in the next problem. We have a negative 3 as a coefficient of the a, and a 2 as the coefficient of the b. So we start with negative 3 times 2. Now I'm going to bring the variables over alphabetically, in alphabetical order. So we start with a to the power of 4 times a to the power of 7. And then we also have this b to the power of 3. Okay. Now let's multiply negative 3 times 2, which is equal to negative 6. When we multiply a to the power of 4 times a to the power of 7, we can add up the exponents since we are multiplying powers with the same base, and that gives us a to the power of 11. This b to the power of 3 cannot be multiplied with anything, so we just bring it along. Part C. In part C, if we look for numbers first, the number or coefficient we have here is the 6. So we're going to bring the 6 over first. The next thing we have, if we look at the variables, I'm going to go alphabetically. So let's go with the m to the power of 5 and bring that on over because there are no other m's. That's the only one we're bringing over. And then we have the n to the power of 8, or rather negative 8, and n to the power of 3. So we bring over n to the power of a negative 8, and then this is being multiplied with the n to the power of 3. So we can simplify this further. Let's bring over the 6, bring over the m to the power of 5, and when multiplying these two powers, which have the same base, n, again we can add the exponents. Negative 8 plus 3 is negative 5. So we get n to the power of negative 5. Now, recall from an earlier lesson that if you have a negative exponent, you can simplify that further, making it a positive exponent. So we're going to do that by bringing it down into the denominator. And I'm starting by keeping the 6m to the 5th power in the numerator, bringing down the n to the power of 5 into the denominator. And remember, the exponent becomes positive when we do so.